Friends, myself Hemant M. Patel, Assistant Professor, Mechanical Engineering Department, Mahatma Gandhi Institute of Technical Education and Research Center, Navshari. Today we are going to discuss about the corrosion in boilers and its prevention. Okay, over here you can see the image how corrosions look like. Okay, these are the tubes, which tubes are inserted into the economizer, air preheater. There are number of tubes using into the boilers. Okay, so this type of corrosion may be occur due to the low pH water we are using into the boiler. Okay, corrosion is the gradual deterioration of metal by chemical reaction with their environment. Okay, we all know about the corrosion which is directly affect through the environment. Okay, so which are the effects? So over here you can see first one, pinpoint penetration of metal, right? So this type of metal may be deteriorate. Second, rusting of ferrous metal. Third, pits can penetrate deep into the metal that can result in rapid, means quickly, failure of feed line economizer tubes. Already I talk about there are number of tubes we are using into the boiler which is directly affect through the corrosion. Okay, so fourth one, ultimate failure of a boiler, metal, steam mains and condensate lines. Okay, over here see impurities in water and its effect on boiler. There are number of impurities we have found into the water. Okay, so first one, dissolved gases. We all know about that in water there are oxygen is present. Okay, so through that impurities, corrosion may be occur onto the boiler surface, inner surface, right? Second impurities you can see calcium salts and magnesium salts. These salts cause scaling. Some salts can also cause corrosion. Third impurities you can see silica, which can form a very hard scale. Okay, so these are the impurities which is found into the water, and due to these impurities, we what are the effects fall into the boiler. Okay, further we can see preventive measures. Okay, so what are the precaution you have to take to reduce the corrosion, particularly in the boiler? So first one, eliminating corrosive gases. Okay, so there are number of gases which is present into the water. So first of all, eliminating that all corrosive gases. Second, removal of dissolved oxygen. Also dissolved oxygen which is present into the water. So first of all you have to remove that particular dissolved oxygen through the deaerator, which is further we will discuss. Third one, high pH value of boiler water. So whatever water we are using into the boiler, that's water having a high pH value. Mechanical deaeration of the boiler water. Higher feed water temperature. Okay, what are the water we are using into the boiler cell, right? So temperature will be higher. Due to that, we can easily reduce its oxygen content. Chemical deoxygenation by use of oxygen scavengers like sodium sulfide. Hot condensate retains as it contains less oxygen than feed water and also saves fuel. So these are the preventive measures, right? So we have to reduce or remove that particular corrosion. Okay, which are the causes? Over here you can see first one, dissolved oxygen in boiler water. Suppose dissolved oxygen which is present into the water, at that time corrosion may be occur. Second, presence of corrosive gases such as oxygen, carbon dioxide, hydrogen sulfide in the boiler water. Third one, sludges of bicarbonate and carbonate. Fourth one, low pH. So already we have discussed about the higher pH level water we are using due to the prevent the corrosion. Low feed water temperature. Last one, acidity imparted to water due to decomposition of carbon dioxide and hydrogen sulfide, H2S. Okay, further we can go ahead. Effective corrosion control requires the following practices. So following practices is required for the reduce the corrosion, how to prevent the corrosion. So first one you can say regular monitoring of the operation. So whatever operation, which are the operation we have particular in the boiler cell, right? So that particular regular monitoring means regular supervision is required. Second, minimization of stress burning startup means whatever stresses fall onto the boiler, that should be a minimized. Third one, maintenance of stable temperature and pressure vessel. So maintenance is required. Particular we are using boiler, so due to the time to time maintenance, it will be giving the best result, right? So control of dissolved oxygen and pH in feed water. Already we have discussed about the dissolved oxygen, how we can easily remove for the reduce the corrosion. And already we are talking about the high pH level water we are using into the feed water for the remove or reduce the corrosion. Regular out of service inspection using established non-destructive technique. There are a number of non-destructive techniques are there, right, for the how to prevent the corrosion. Okay, prevention of corrosion in boiler, inner surface corrosion prevention. Okay, so in boiler we all know about that there are a number of tube we are using in which inner surface and outer surface of that particular tube, right? So right now we are talking about the inner surface, right? Boilers inner surface tube corrosion, how we can prevent. So first of all, addition of adequate amount of scavengers like hydrogen sodium sulfide, right? So adequate amount of scavenger we are adding in particular inner side of the tube to remove dissolved oxygen for protection against pitting of inner tube surface. Second, deaerator in water treatment plant to remove dissolved O2 and CO2, oxygen and carbon dioxide. Right? Deaerator generally we are introduced in the feed water treatment line. Due to that, suppose we are inserting deaerator, at that time what happen, we are supplying the little bit steam into the deaerator, and whatever feed water which is passing through the deaerator, at that time what happen, this dissolved oxygen and CO2 will be reduced, will be removed from particular the feed water. Third one, addition of ammonia for neutralizing amines in water and lowering pH value of water. Effect of CO2 get neutralized. So over here you can see ammonia you can add into the inner surface of the tube due to the neutralize the carbon dioxide. Addition of alkali salts in water, so neutralizing acids. Addition of ammonium hydroxide in water reacts with carbon dioxide to form ammonium carbonate and water. So effect of CO2 get neutralized. Applying protective coating of amines on boiler tube inner surface. So over here suppose this type of corrosion may be occur inner surface of the tube, at that time some addition is required like scavengers, deaerators, after ammonia, alkali salt, ammonium hydroxides. So suppose we are addition particular this content, at that time what happen, neutralize CO2 oxygen easily we can remove. So due to that we can prevent the corrosion inside of the boiler tube. Right now we are talking about the outer surface corrosion prevention. Okay, so outer surface of the boiler tube also maybe occur corrosion, right? So passing some air around preheater, right? So some air which are the passing through the preheater, at a time what happen, this type of salts sediments will be thrown away from the outer surface of the tube. Recirculating air from preheater outlet to forced draft fan inlet. So recirculate, right? Generally we are using air, particular how to uh, clean the tube at the time, recirculating air from the preheater, right? At the time forced draft fan we are using, removing deposits of soot regularly from the surface of economizer, superheater, evaporator tubes, air preheater, reheater, etc. Right? So we all know about that there are number of components we are using in boiler: economizer, superheater, evaporator tube, preheater, right? So particular on that component also deposit such type of soot, so that should be regularly clean by the particular precaution you have to take, right? After, you can see heating feed water with steam from boiler in cell and tube heat exchanger to prevent low temperature corrosion by feed water. So over here you can use uh, feed water, right? We are using feed water into the boiler at that time, little bit heat, right? Because of the hot flue gases will be generated after the combustion of the fuel, right? So we are using that particular heat for the water to heat before we are entering into the boiler, right? So due to that particular uh, these are the outer surface corrosion preventions measures. Okay, further we can go ahead. In coal based thermal power plant, following type of corrosion are possible, right? So in thermal power plant also we are using a main component of the boiler, so there are also some types of corrosions are possible: water, gas, acid corrosion, high temperature corrosion, low temperature corrosion, oil ash corrosion, stress corrosion, and fatigue corrosion, right? So first of all, over here you can see high temperature corrosion, so in which there are certain contaminants, like you can see vanadium compound, sulfate compound. Okay, over here you can see the figure, right? You over here you can see this figure, this image. In high temperature corrosion means this type of corrosion may be occur at that time, that particular component will be break easily, right? Okay, further you can see low temperature corrosion due to the using fuel with sulfur in steam generating units yield potential hazard sulfur corrosion at the cold end of the boiler. Sulfur in the fuel is oxidized simply or to sulfur dioxide during combustion. Some sulfur trioxide is also formed and combines with water to form sulfuric acid, which condenses on the and attack low temperature boiler surface. So over here you can see into the image this type of corrosion may be occur due to the low temperature, right? So same type of corrosion over here in next figure, oil ash corrosion. So over here what happened, all fossil fuel with the possible exception of neutral natural gas contain constituent that will promote corrosion on the far side of boiler component. So over here fly ash and soot blowers are not by themselves corrosive, but both remove the protective iron oxide layer. So this type of fly ash and soot blower, which is both we can connect with each other at that time, it remove the protective iron oxide layer. So that's why this type of corrosion may be occur, right? So the clean steel is then exposed to the high temperature flue gas environment and an oxide film reforms. Further you can see another corrosion, stress corrosion. Stress means particular, we can generally we can select that stress load by area. Stress corrosion may result in either inner intercrystalline or transgranular cracking of carbon steel. It is caused by a combination of metal stress and the presence of a corrosive. So over here you can see the image, this type of stress corrosion may be occur, right? So this is another corrosion. This is a stress corrosion. After fatigue corrosion, generally we all know about the mechanical properties. There are a number of mechanical properties, right? Stress, strain, ductility, malleability, fatigue, creep. Right? Fatigue means what? The failure of the amount with repeated load, right? Particular one part is there, and at that time we are giving the repeated load on particular that same point. At that time that material will be fail. That is known as the fatigue. Corrosion fatigue is fatigue in a corrosive environment. It is the mechanical degradation of material under the joint action of corrosive and cyclic loading, right? I already told about the cyclic means repeated load. Whenever we are giving in particular part, at that time that material will be fail. That is known as the fatigue. So additional thermal stresses could be imposed on the end tubes from the boiler frames, right? So prevention of corrosion. So right now we are talking about the there are a number of impurities in feed water. So at that time suppose feed water treatment. So over here you can see aeration, deaeration, ion exchange, chemical treatment, protective layers in boilers, right? So basically simple, we are using deaerators. Okay, so deaerators are used to heat feed water and reduce oxygen and other dissolved gases to acceptable levels, right? So generally we are using deaerators in thermal power plant to reduce the oxygen and dissolved gases, right? So deaerator in right now just we are supplying little bit steam, and after this type of dissolved gases will be easily removed, and after feed water which is goes into the economizer, and after economizer it goes into the boiler cell, right? So most corrosion fatigue cracking has been reported to be the result of mechanical factors such as manufacturing procedures, poor welds, and lack of stress relieved welds. Operational problems such as water steam hammer can also be factor, right? So deaerator, over here you can see in this figure, right? From over here we are supplying the boiler feed water, right? Now over here you can see trade section. So there are a number of perforated tray we are using, right? And after over here steam which is we are supplying to the upward direction. At that time both in contact with each other, right? So over here what happened, whatever dissolved gases in the boiler feed water which is uh, goes into the steam to the upward direction. So air vent, over here you can see air vent. So dissolved gases which is passes through the over here, right? So after this deaerator water we are using into the boiler feed water, right? So deaerator is generally nothing but just we dissolve, we can reduce the dissolved gases like oxygen, carbon dioxide, remove that particular water, and after that feed water which is passing through the pump. So this type of pump bubbling will be reduced, and easily water which is goes into the upward direction into the economizer, and after through the economizer it is passing into the boiler cell, right? So this is the deaerator. Okay, so basically deaerator we introducing into the line of the feed water, right? After feed water we are gathering the water through the river. After feed water treatment plant, this water which is passing into the deaerate. After the deaerator, this water goes through the pump into the economizer and into the boiler cell. Okay, so this is the generally which type of corrosion may be occur through into the boiler cell, boiler outer surface, boiler inner surface, and how we can reduce, which are the content we are introducing, adding into the water to remove such type of salt, such type of uh, impurities, right? So this is the basic thing, how we can reduce the corrosion through the outer surface and inner surface through the boiler, right? Thank you.